How do fish orientate themselves underwater with such ease? Anybody who has been unlucky enough to open their eyes whilst under the sea will tell you how dark, cloudy and disorientating the experience is, not to mention painful to the eyes. So how do fish make it look so easy? Much of this is due to a biological phenomenon known as electroreception, a unique sensory ability which allows fish to distinguish and respond to electrical signals. This ability is found exclusively in aquatic and amphibious species. This is probably because water is a good conductor of electricity. Electroreception comes in two forms, active and passive. While all animals produce electric signals, which are involuntarily created by the nervous system, some animals have the ability to receive and decode electric signals generated by other animals in order to sense their location. This is called passive electroreception. Other animals can go even further. Creatures that use active electroreception have organs that produce unique electrical signals at will. These can be used to send out mating signals and to ward off rivals. They can also be used to find things in the water. Active electroreceptors can make the distinction between the different resistances that their electrical currents experience. This can assist them with recognizing whether another animal is a predator, a rival, or prey. Active electroreception has a range that extends to the length of the creature's body, which is normally just enough for the creature to avoid danger or attack. One interesting way in which active electroreception is used is the jamming avoidance response mechanism. This has been seen between individuals from certain species known as weakly electric fish. If two weakly electric fish encounter one another in the ocean and they are both using the same electrical frequency, each fish will simultaneously change the frequency they are using. This is done to ensure that they do not mutually jam their signals. Many years ago, citizens' band radio clients would argue with other people who were transmitting over the same frequency. It seems like electroreceptive fish have found an amicable way to resolve this issue. Another benefit of electroreception is in its ability to ward off predators. One example comes from rays. Embryonic rays that are growing within an egg grow on the sea floor. To breathe through the shell casing, these embryos need to keep their tails moving. However, should their movement catch the eye of a predator, they may be in danger of being eaten. Electroreception within the embryos allows them to cease movement in the presence of a predator and also stop transmitting electrical currents until the predator is at a safe distance. As there are many creatures in the sea, rays have evolved to only employ this tactic in response to electrical signals that indicate the presence of potential predators, such as sharks. Sharks are some of the most fearsome predators in the ocean. For this reason, it is unsurprising that many people are afraid of swimming in the open ocean. While sharks possess keen senses, perfectly adapted for the sea, humans, by contrast, are ill-equipped to oceanic survival. When hunting, sharks begin by honing in on their prey through a keenly accurate sense of smell. Indeed, most of a shark's brain is dedicated purely to interpreting scents. When the shark closes in on its prey, its electroreceptive senses guide it to catch its prey. This system is so effective that sharks need not even rely upon sight and may close their eyes to protect them. Most shark attacks on humans are accidental. Often a shark attack against a human is non-fatal, as once the shark is aware of what prey it has captured, it loses interest and releases the person. Whilst electroreception is a formidable weapon for hunting, it does nothing to inform the shark of how the prey will taste, and sharks tend to prefer fatty prey such as whales and seals rather than leaner prey such as humans. Despite this, once a human is bleeding, other sharks may be drawn to the blood. The strength of the electric field increases with the addition of the salt in the blood, which may draw in additional sharks and other predators. In locations that are known for shark attacks upon humans, the scientific community is working to develop fake electroreceptors that can confuse sharks and drive them away from areas where people swim. Our collective knowledge of electroreception is still lacking. Despite the fact that scientists have collected information on how electroreception changes hunting and defense patterns, as well as how creatures communicate, they are still unsure of how the neurological processes to encode and decode this information work. Scientists are also interested in how electroreception affects navigation. Some hypothesize that the Earth's magnetic fields may interact with salt water to produce electrical currents that fish may use to navigate long distances.